Alright, welcome to the bomb calorimeter. We're going to start the lab. We have the half of the calorimeter in our fixture, and we're going to load our wire. This is fuse wire. We're going to load our fuse wire in. So we're slightly above our cup. And we're now going to add 3 cc's of methanol to our cup using a standard syringe. Now that we have our fuse wire attached and our fuel loaded, we want to make sure that we get a good seal on the grease. We just, before we started filming, added some grease to our seal. So we'll make sure that we have a good seal there. Then we'll take the top half of our calorimeter and install it onto the lower half. We'll do this carefully as not to disturb the fuel in the cup. And we'll make sure that this seal is good and tight. So right now we have our fuel in there with our ignition wire, and what we're going to do is we're going to add oxygen. So we're going to open our valves. I just opened the exhaust valve, and this is the intake valve, and we're going to fill the volume of the vessel with pure oxygen. We have the oxygen regulator set at 120 psig. I've already got the regulator on, but I've got a small valve closed. So open the valve. Now we have our intake valve open and our exhaust valve open. And what we're going to do is purge out all the atmospheric contaminants that are in the chamber. So it's going to purge out any of the air, unneeded moisture, nitrogen, whatever else is in our atmosphere right now. We're going to let that go for about 30 seconds. And I don't know if you can hear, but it's starting to hiss louder, so that means that we're coming up to our pressure. We're evacuating any of the contaminants that I spoke of. And once we're at about 40 seconds, we'll close the exhaust valve. And now our exhaust valve is closed. We'll let the chamber pressure stabilize, and then we'll close our intake port. We'll close the valve on our regulator. And we'll remove the hose from the vessel. We'll put our CPC connectors together, which ties our pressure transducer into our data acquisition cable. And now our vessel is ready to be loaded into the water chamber. Refill. Okay, now we have our vessel is in our water chamber. I'm going to connect our thermocouple for the chamber and connect our second CPC connector to our data acquisition. So we have 2,000 cc's of water in our water vessel, in our water chamber I should say, and we have an electric pump which circulates the water. By turning on the water pump, we're going to keep the water temperature stabilized around the vessel. So now we're ready to ignite our mixture. So what I'm going to do is I'm going to start our computer program, which runs LabVIEW, and I'm going to turn on the power supply to our system. So now we can see that we're right about 8 atmospheres. Our water temperature is about 30, and our chamber temperature is about 30 C. Now I'm going to trigger our fuse wire to ignite right now. We can see we have an increase in our pressure, and on our chamber temperature is increasing. The chamber temperature is still increasing. Our pressure is starting to decrease. And once we get to our peak temperature, our temperature drops and our atmospheric pressure drops quite a bit. Now we let the program run. So we have a water temperature about 30 C. The chamber temperature peaked out about 410 C. And our atmospheres are continuing to drop, and we're about 6.5 atmospheres right now. It's an interesting phenomenon to discuss, is why our atmospheric pressure is now lower than when we started. And we let this program continue until both of our temperatures have equalized. Okay, so now our program has completed. Our temperatures have virtually equalized, and using our data file now, we're going to be able to look at our information and see how many calories were used in combustion. Now we're going to open up the chamber and look at the contents. So after all of our fuel has been consumed, you see that we have quite a bit of moisture that is condensed on the inside of the vessel. And all of our fuel has been consumed and the fuse wire has been burned.